Hello there, algebra students. This is Mr. Kashi speaking. With this video, we're going to be going through how to solve quadratic equations by factoring. So we went over this strategy with expressions in last chapter, in chapter 10, but now what we're doing is we're adding this equation part to it. This equals to 0. So a lot of this will be the same except for just that that zero product property piece that we added on from our last video. So if you can remember, we have x squared plus 11x plus 18 equals 0, and that is going to be from our standard form, ax squared plus bx plus c equals 0. And so what we're going to do is we have to find two factors that multiply to 18 but add to 11. And if you take a look at your factor sheet, it would be 2 and 9. So then we're going to split this up and say x plus 2, x plus 9 equals 0. So all we did in that step was we took it from standard form and we put it into factored form. And we put it into factored form because now this will be our zero product property. So a times b equals 0, right? So we have to find out what makes each one of these equal to 0 to find out where our x-intercepts are. So here we have x plus 2 equals 0, and we have x plus 9 equals 0. And then here, we just, to solve for x, we subtract 2 on both sides, x equals negative 2, and we subtract 9 on both sides, x equals negative 9. So our two answers for this quadratic equation would be x equals negative 2 and x equals negative 9. Got a couple more examples for us. So sometimes they're not always going to end up starting on the same side of the equation. So here we must have our standard form equal to 0. This is very important. And so here what we would have to do is we just have to subtract 16y on both sides. So here we would have y squared minus 16y plus 48 equals 0. That's very important. We can't go on from there until it's equal to 0. So then we need to do our diamond method. So we have 48 and negative 16. So we need to find two numbers that multiply to a positive 48, add to a negative 16. So this would be negative 4 and negative 12. Those add to negative 16. And then that positive times a negative times a negative would equal that positive 48. So then we can split this up. We go y minus 4 times y minus 12 equal to 0. Now it's in factored form. So then we use that zero product property. We just set each one equal to 0. Like that. And then just simply add 4 on both sides. Y equals 4. Add 12 on both sides. Y equals 12. So those are our two answers to that equation. And if we were to plug those back in, they would still get 0. So if we were to plug in a 4 in for y here, we would get 0. If we were to plug a 12 in for y, we would get 0. Now moving on to another example that doesn't have a 1 out front. So here we have this 2a squared. And hopefully you remember from last chapter we had something called the AC method, which means that we are multiplying our first number and our last number together. And that is going to affect our diamond. So this would be 30 right here and negative 11. So we need two numbers that multiply to 30 but add to negative 11. And that would be negative 5 and negative 6. Now, unlike the last time, we have to do a little bit more work here. So we're going to split up this negative 11 with negative 5 and negative 6. So we'd say 2a squared minus 6a minus 5a plus 15 equals 0. Then we'd split them up like that. And then we have to factor out as much as we can from each side. So this would be 2a. We can factor out that from both sides here. Then this would be a minus 3, just like that. And then here we're going to factor out a negative 5, and this would also turn out to be a minus 3. And so now what we need to do is we just need to bring these two together. We have 2a minus 5 times a minus 3, and that equals 0. So then, now that we're to this point, now everything's the same that we've had before. We just set both of these equal to 0. So we have 2a minus 5 equals 0, and we have a minus 3 equals 0. So over here we have plus 5 and plus 5, so we have 2a equals 5 divided by 2 divided by 2. A equals, I would just leave it as 5 halves, or you could say 2.5. And then on the other, with the other equation, we just add 3 on both sides. We have a equals 3. So those are our two solutions for that quadratic equation. And then the last one is a lot like that, but we have two things on the wrong side. So I would always want, in this situation, if you think about, we have ax squared plus bx plus c equals 0. We always want to have ab positive if we can help it. So instead of just subtracting 2w squared, I would subtract 9w on both sides. So we get 2w squared minus 9w equals 5. Then I would subtract 5 on both sides. I know it seems like a little bit more work, a little bit more inverse operations, but I would highly advise keeping a positive in this case. So now that we have everything on the same side and it's equal to 0, now we'll do our AC method, so 2 times negative 5. So this would need to be negative 10, and then we have a negative 9. So they need to multiply to negative 10 to add to negative 9. So that would be negative 10 and a positive 1. So then we're going to split that up. We're going to split that. We have 2w squared minus 10w plus 1w minus 5 equals 0. So then we have to draw our line, factor each side. So here we're going to factor out a 2w, and then that would mean that this is w minus 5. And then on the right-hand side, between 1 and negative 5, we can't factor anything out. So we're just going to factor out a 1, and then we still have the w minus 5 there. So then we're going to bring these two together. We have 2w plus 1 on the one side, and then w minus 5 on the other. That's equal to 0. And then the last thing we need to do is set both of these equal to 0. So we have 2w plus 1 equals 0. And we have w minus 5 equals 0. So here we subtract 1. We get 2w equals negative 1. Divide by 2. W equals negative 1/2. And then on the right-hand side, we just have adding 5 on both sides. W equals 5. So those are the two there. So whenever you have something out front that